Hi, my name is Lior Fishman. I'm Associate Professor in the Math Department. And today I'd like to talk to you about research. My area of expertise is number theory, in particular something which is called differential approximation. And over the years I had the pleasure of working with many people in my field, including very well-known professors, but also with postdocs, grad students, and even undergrad students. Math, just like any other discipline, is a community activity. We are not working alone. Whenever you are working on research, whenever you're discovering something, whenever you're thinking of a new idea, you're part of the math family. It is important to understand that a lot of what is done now in math research, and if you look at famous papers written right now, it's very common nowadays to have 2, 3, 4, 5 people working on a common project. The title, Best Possible Rates of Distribution of Dense Lattice Orbits in Homogeneous Spaces. No, but they have a whole discussion about best possible Diophantine exponents, right? Yeah, okay. I'm still not convinced that this is our case, right? I'm suspect. To be honest, from my personal view, I love this. I love working in a group. I love collaborating with other people. I think it makes the experience by far more enjoyable. It alleviates the stress out of doing things by yourself. And also you get a lot of perspectives from other people. And the nice thing that you get perspective from other people, even if they are undergrad students. Sometimes you get some new and fresh ideas, some kind of new viewpoint that we just miss. And so the idea of working together with the whole spectrum of mathematicians, starting from undergrads and ending with the most well-known professors you can think of, is extremely exciting. And you can tell I'm very passionate about what I do, and I'm very passionate about math, and I'm very passionate about working with undergrad students, with grad students, and with basically anyone who wants to listen and anyone who wants to put in the work. I want to talk more about what we do in this very exciting research project that we call the incubator. This started about 2 years ago. I think this is kind of missing the point of this left, right thing, because every time you hit a point where you can't continue, let's say to the left, he just adds a 0, and then the thing just continues to the right. You can make sure that he has a lot of even terms or odd terms, just making sure that the direction is clear. I think that what Taylor and I are suggesting is harder, because you can't take advantage of this. You have to keep moving left, right, and still find a sequence which agrees with the decimal expansion. There's something which is kind of tricky, is understanding, explaining what pure math research is all about. Most of you have seen research in other fields. You have done some kind of research when you were turning in a history paper, conducted experiments possibly in physics, in chemistry, in biology. But research in pure math is slightly different. We don't go outside to the real world and collect data. We basically come up with questions which are to do with a set of axioms and ideas within the field itself, and try to come up with solution or interesting ideas, again, not necessarily connected to the outside real world. For example, I'm currently working with 2 collaborators on a very interesting project. One of them is at Brandon University in Boston. Another was a PhD student. He graduated from Brandeis University, is now working for Google. It's fascinating how we can come out with new ideas, new problems, new solutions, working from very different perspectives. I want to introduce extremely exciting and a project which I'm very passionate about, which we started in our department about 2 years ago. We decided to kind of shake things up a bit, and the idea was to break up the traditional form of this research by having PhD students advise the undergrad students and collaborate on research projects, with the role of the faculty more of a monitoring or supervising, but most of the interaction on the research was done between the undergrads and the grad students. We currently have 7 to 9 different projects going on, advised by 4 PhD students. 2 of the projects have been finalized. Those are going to be sent to for publication in journals. So how was the research initiated, and how does it actually work now? So we started meeting over the summer of 2019, in which graduate students introduced what they are interested about. The undergrad talked about what they would like to do. I presented a few questions and ideas that they might consider working on. But it's important that it's all done in a kind of very democratic way. I mean, everyone could come up with any questions, any ideas, any suggestion, and we kind of discussed all of these over about 2 or 3 weeks until we converged to, 4, 5, 6, 7 different groups working on different projects. So currently we have 9 projects in process involving more than 20 undergrads, including TAM students, and being mentored by 4 PhD students. The groups are meeting independently, and some of the students decide to work on multiple projects. So the fact that they are working on one project doesn't mean they're not working on another project. The projects' topics are very diversified. One of them is, some of the projects are on mathematical games, other are in algebra. There's another 2 or 3 projects actually in graph theory. I am currently starting a project which is very much involved with number theory. And if anybody came up and anybody wants to work on another project to do, anything else, he or she are more than welcome to do so. We actually have some ideas of working in related projects to computer science and imaging, which I'm kind of toying about with. Hopefully somebody will pick it up. The idea is that I don't want to be the person telling them what to do. I want the undergrads to be enthusiastic, motivated, interested, that they could come up with something that they're interested in. And my role is to basically introduce them to grad students, for the grad students to be involved as well, and for those projects to just keep running. Everything has to come from a place of passion and love. I am game for almost any idea students can come up with. The grad students are extremely happy to work with anything the undergrad students would be interested in. And I'm saying it because right now we are mainly working on projects which are in pure math. But if somebody is thinking about a project in math education, for example, an interesting idea would to see some kind of effect of Zoom learning versus traditional learning. It's just an idea. If somebody is interested in the philosophy of math, he or she are more than welcome to suggest such an idea, and I'm sure we can find something to work together. There's a lot of interesting, amazing topics in applied math right now, and in biology or in chemistry, in computer science. If you're enthusiastic, if you're passionate, if you want to do it, we'll find a way of doing it. We'll find the grad students who will be more than willing to advise you. And we'll find a way for you to publish your results, for you to introduce the result, to present them in conferences, to present them to the faculty. It's up to you. If you want to do it, we'll be more than happy to help you out. Right now we have about 7 faculty members who are very much interested in this project, and their research interests are extremely diverse, ranging from logic, set theory, foundation of math, through math education to analysis, function analysis, and geometry. I really want this project to grow. This project depends heavily not on me being enthusiastic about it, not about the other faculty members being enthusiastic about it, it's about you being enthusiastic about it. The grad students are extremely enthusiastic about it. They chose to do math. They love teaching math, and they love doing research in math. For you, undergrad, this is a brilliant chance to interact with your future community, with your current community, obviously, but also with future community. I mean, there is kind of a conception in the public that, I don't know, mathematicians are those bizarre people sitting in their rooms doing. It's not. We are a community. We work as a community. We care about what other people are doing. They care about what we do. And it's a good, I think it's a unique opportunity to get into this idea of not just studying stuff, but actually, researching stuff by yourself, challenging yourself day in and day out. And at the end, not just getting a good experience, so to speak, but you also have, hopefully, published papers. You're going to conferences. So for those of you who want to continue in math, you have to do this. I mean, you really have to do this. But even if you're not continuing in math, suppose you're what you want to do is you go to UNT for 4 years, you get a degree, you get a 4.0 GPA, and then, for example, you really want to go to Harvard, you want to go to Stanford, you want to go to MIT. Totally reasonable. If you have those skills under your belt, if you have those things in your CV, if you can say, not only I'm a good student, but I was also involved in research, I was involved in writing papers, I have papers with my name on them, I have conferences in which I presented going forward. You cannot imagine how much impact this carries when you apply to those high-end schools that so many of you are thinking about. I think, and I truly believe in it, that the unique opportunity not only to go to a good school like UNT, not only challenging yourself with your classes and your grades and whatever else you have to do in order to stay and be successful at UNT, I think that the experience, the research experience, the community experience that you get, your interaction with grad students, your interaction with faculty members, understanding what math is about. And again, I'm saying it, I'm a pure mathematician, but you have other faculty members who do applied math, exciting things in applied math. And it's also your chance to say what you want to do. For example, you read something on Wikipedia, you saw something on the internet, somebody mentions something. What are those Catalan numbers? I mean, you can have and they come to us and we say, okay, I don't know. I mean, one of the projects I'm working on, I'm supervising now, is about something which I've never heard of in my life. It's in my area, but I've never heard of this thing. One of the grad students, he's not my grad student, one of the grad students at UNT said, what do you think about this? I said, sounds brilliant. And we started to, involving more and more and more students. Now there's a group of about 8 students working with this. In my opinion, it's going to be an amazing project. It's an experience that is extremely valuable for you all, regardless whether you're 16 or you're 57. This is a once in a lifetime experience if you're not in math, and maybe it will convince you to stay in math for the rest of your life.